Before that, I would like to welcome you all to this Big Data Hadoop session. My name is Nambi, and I've been in the IT industry for last 10 years, mainly working on the data warehouse technologies. I have mainly worked on ETL tools like DataStage, Pentaho, and Informatica. And now, from last few years, I'm mainly into the big data technologies. I extensively work on Hadoop and it's some of the ecosystems like Headspace, Phoenix, Spark, and Scala. So these are the big data technologies I extensively work on. Okay, before I move on, may I just know the idea for today is I'm giving an introduction to big data. So let's understand what is big data, and because most of us have a confusion between big data and Hadoop. So we understand big data, Hadoop, and I'll give an introduction to HDFS architecture. So that we get familiarized with the terms of this architecture and the features of HDFS. And if time permits, I'll also introduce to Hadoop ecosystem. So some of your doubts, like whatever Sri Prakash had, we can try to cover it. Okay. So let me begin with the big data concept. So I'm sure this is the buzzword in the market today. So what is big data? So the name itself says big data. Big means how big it is. So big can be different in different versions. Like big data was different 10 years ago, big data was different 5 years ago, and moving forward, the big data might also be different, right? So big is that the volume of the data? Yes, certainly it was a volume for us a few years ago. But now big data is defined in a different way. So we say it has a characteristics of 4 V's. So what are those 4 V's? One is the velocity, the volume of the data, the variety of the data, and one more is veracity of the data. So when I say volume, so just imagine the amount of data that we are generating every day by a single person. As an individual, we generate data like sending emails, uploading videos on YouTube, tweeting, or sending emails, WhatsApp, how many photos you send, how many messages, and how many videos you send. So this is the volume of statistics for this. So every minute, we are sending around 204 million emails, and around 100 hours of videos are getting uploaded in YouTube every minute. And this is the volume of the data plus the velocity of the data which is getting, the speed or the velocity with which the data is getting generated. And the variety. So you can imagine we are generating pictures, we're generating videos, text messages, logs, and so many types of data. So this also forms the big data. And the veracity. The data in the world is uncertain. So we cannot believe that our source data is completely accurate, or it might have a poor quality, or the data that we are getting may not be true. So a lot of things needs to be processed before we actually bring up the analysis. So this different types, or if we define big data, it is for us now, if we have to define the volume of the data, it might be in the multiples of petabytes or zettabytes, and which has these 4 characteristics. So today we define big data with these 4 V's, and we define big data with those 4 V's. And why big data? The question comes, yes, you have data of different types, which is coming generating very fast and with a huge volume and with uncertain or poor quality. So then why do you need this big data? So big data has become very uh, what do you say very useful in this today's digital world. So if you have been in the data warehousing I mean, if you have worked in the data warehousing concept, so you know that the data is stored as a history and it is processed later, right? But how much data you can store? How much data you were able to store? If you remember, 4 or 5 years ago, it used to take almost a day to load our data warehouse. And after the data is loaded, we have to do the analysis or we have to give the report. So it was almost taking more than a week to give the entire report. But today, the world is not waiting for a week for your analysis or for your report. And also, the amount of data that is getting generated is so much that our traditional systems are not able to handle this big data. So that's the reason we have a new era coming into picture, that is Hadoop. So Hadoop is an open source a Java-based programming framework which can store our data and as well as process the data in a distributed environment. When I say and store and process, it is not a small amount of data. So what we say is a big data. So if you take our traditional RDBMS systems, which it can store a structured data, right? But our Hadoop can store structured, unstructured, and semi-structured data. Or this is the technical term definitions, or you can, as I said, the 4 V's of data, of big data can be stored in our Hadoop. It's not just storing the data, it can even process that data. So this has the capability of the big data issues or the data issues that we are facing today. So you name any one, any business, the big business which is happening. It can be in the retail industry or in the social network like Amazon or Facebook. They all are using the big data technologies to process and analyze their data. And the retail industries have improved around 60% of their profit. And our retail industries are able to predict, so what could be the market in a few months, or what is the customer looking for, what type of customers are coming in. Based on that, they can improve their market. So these are the some of the very live examples that we have in front of Hadoop. And Hadoop is also going to become a 50 million dollar market in the world by 2020. So that is the scope of Hadoop that we can visualize for future. Okay, so if you go online or if you just search for Hadoop, you see a small baby elephant picture, right? So that is, it's just a name of the toy of Mr. the creator, Duck Cutting Skit. Okay, all right. So this gives, I'm sure you now you can differentiate between big data and Hadoop. Right? Big data is the data. A Hadoop is a way to store and process. So that's the only difference. But there are so many other components and architecture and the processing happening in Hadoop that we'll explore one by one. Okay. So I hope the difference is clear and we know what is big data and Hadoop so that we can move on to the components of Hadoop. Okay. All right. So just to give some heads up on this Hadoop, it is Apache Foundation project. It is a completely open source. You can download and use on your system. And if you search for Hadoop, you might see multiple vendors like Cloudera, Hortonworks, and Mapper. So you may not get confused with these. So which one should I use? So you can go for Apache Hadoop for now because it's completely free and open source. And this Cloudera or Hortonworks or Mapper are mostly customized according to the enterprise requirement. So for example, if I own a company and I say I need Hadoop, I just need Hadoop. I don't want to process the data. I just want to store the data. So for that, they'll customize and give you the storage, and they'll also give the support. So it is paid. Okay, so mostly some of them are uh, freely available for some time, but mostly they work for the enterprise. So based on the requirement, they give some additional functionality and give it as a package, so that everything is in one package. Okay, so don't get confused. You can just concentrate on the Apache Foundation, Apache Hadoop for now. All right. So now I'll get into the components. What are the components we have in Hadoop? So I said Hadoop can store the data as well as process the data, right? So where the data is stored and how the data is processed, let's have a look. Okay, so you can see two things. One is Hadoop 1.0 and another is Hadoop 2.0. Hadoop 1.0 was the previous version. So now whatever the versions that we are using, it's only 2.7 plus, so 2.7.2 or 2.7.3. So this is the latest version we have been using. It is completely open source. Okay, we can download and Hadoop version of the previous version we used to use. So let's just understand what the components we had. We have two basic components. One is HDFS, that is Hadoop Distributed File System. This is exactly where our data is stored. So we have a storage part in Hadoop, right? That is HDFS. So what does MapReduce? This does the processing part. So you have the storage, which is HDFS, and you have the processing part, that is MapReduce. So HDFS stores the data in form of a file system. It is nothing but a file system. You can just imagine as your file system. And MapReduce is the processing system. So this is written in core Java. So HDFS understands core Java. So in a 1.0 version, you have to know core Java to write the MapReduce programs. Okay, so that are the features of Hadoop 1.0. So now if you come to 2.0, you have some additional components here which has been made easy to everyone. Okay, so the basic part is HDFS to store the data and MapReduce to process the data, and we have two more components here, Yarn. So Yarn is yet another resource negotiator. So this manages all the resources within the Hadoop cluster. So you might have a question. So who did that management or the resource management in Hadoop 1.0? It was MapReduce who used to do the resource management. Since it was a burden to MapReduce, that has been split to another service that is now separately called as Yarn. Okay, so we can get into details of Yarn architecture in the future classes. And next, the others. So what is this others? A very important part. So people who know Java, who knew Java, could write MapReduce programs because they are written in core Java. And however, people like me who come from a different background where I have no idea of Java, I mainly know SQL, I mainly know PLSQL, and so how people like me, and some people are very good in Python, and some people are very good in scripting. So how would we ensure that they also use Hadoop extensively? So for that, the reason Hadoop introduced, or different companies introduced different data processing systems, so that you don't have to write MapReduce programs. You can use other ecosystems with which you can extract the data and process the data. Okay, so we'll understand what are these other data processing systems that we have, or other we call them as ecosystems. Okay, in Hadoop. So with that, we can understand or we can use the HDFS data very effectively. Okay, so these are the very components of Hadoop. So this is the latest version. So you can see the components here. Mainly the components that we have for HDFS and MapReduce with Yarn. and some of the other processing data processing tools that we have to use the HDFS data. Okay, so these are the very core components of our Hadoop. So you can take a look, and if you have any questions, let me know. Okay, so assuming this is clear, I'll just move on to the features of HDFS. So before I actually get into the features of HDFS, let me just give a small introduction to the components in HDFS. So I'm just taking the two components, right? So one is HDFS, another one is MapReduce. So I'm just taking the HDFS. This is the Hadoop distributed file system where exactly the data is stored. Okay. So before we get into the features of HDFS, let me just give an introduction to the architecture so that you can easily relate the terms. Okay, so by looking into the picture, yes, you might see it looks complicated. So to make it easier, I'll just glance through the names. You can just have a look at it, and I'll just give an overview for now so that you just get familiarized with these terms, and then we can explore each one of the each function separately in the when we get into deep of HDFS architecture. Okay, so first, this is name node. Okay, and we have another service called as data node. Data nodes, and then we have the data nodes are these square boxes highlighted in light yellow, and the blocks which are in green, and there's another term called rack. And a very important one is the replication. And you can see one more term called as block operations and metadata operations. And you can see client here. So here the client is writing the data. Your client is reading the data. Okay. In name node, you can just remember this metadata. Okay. So just have a look at this architecture. So I'll let you know what are these. These are the very important terms in HDFS needs to be known. Okay. So in the next session, I will also show you the Hadoop installation where you can see all these services up and running. So if you want the HDFS architecture or HDFS up and running, these are the services, that is name node and data node. These are the very important services. They should be up and running. Okay. So hope you have taken a glance at these, and then so that I can explain each one of them. Okay. Okay. So this is a very basic architecture of our file system where exactly the data is stored. Okay. So where is our data stored? Data is stored in the data nodes. So that's why you can remember it as data nodes. So each storage or you can say it's a system. It's one system where you can store the data. So this is one is called as data node. And you can imagine another system where you have some capacities to store the data, and this is another data node. We have 3 data nodes here. So the data is distributed across the data nodes, right? So that's the reason it is called as a distributed system. The Hadoop architecture is designed in such a way that the data is distributed across the data nodes. so that the processing can be done parallelly. So this saves the time of the processing. So that's the reason the data can be stored in multiple systems. So you can have you can store huge amount of data because you can easily add the data nodes, and the data is processed parallelly in the data nodes. So that's the reason it is called as a distributed processing system. Okay, so now you see one more thing within the data nodes as blocks. Okay, the small green color boxes are called as blocks. So what are these blocks? So what happens is, so I said the data is distributed. So how is that distributed? Let's take a look at this. So I'll just place this. Okay, now you can see the client here. The client might request to write a file. Okay, there is one file. The client wants to write that file into your HDFS. So just let's imagine that has 128 MB of data. Okay, the default storage in each block is 64 MB, but going into the higher system, it also has 128 MB. For now, we'll imagine that the storage of each block is of 64 MB. You might ask why 64 MB? That is a minimum amount of data that can be processed by our HDFS. So that's the reason it is 64 MB. So I have a file with 128 MB of data. So I want that data to be written into HDFS. So how this happens is, this 128 MB is split into the multiples of 64 MB. So if I do that, so here I'll get two blocks. So one block will be written somewhere here and another block will be written somewhere here. Okay, so now your data or your file 1 is distributed on data node. So we can say this is a data node X and this is a data node Y. So data node X has one block and data node Y has two blocks. So these are the blocks. Okay, so now a question arises: what happens if the system crashes? So what happens if the system crashes? You will lose some part of the file, right? And you will have only this file. So there is no meaning. You have only half. You don't know what data is available in block 1 because we cannot look into that, but we can visualize that this is how it is distributed. So this becomes meaningless. So for that, Hadoop has a solution called as replication. By default, the replication factor is 3. So what it does is, I wanted my data to be safe. You want your data to be safe, right? So what it does is, it ensures that when the data of your file 1 is distributed into two blocks, block 1 and block 2, it ensures that this block 1 is also saved somewhere else. So probably here, as I said, replication factor is 3. So it will be distributed into some different systems based on some algorithm that happens within the system. So that is called as rack algorithm, which we don't have to know it, but it ensures that our data is distributed safely. Okay, so if the system crashes, this becomes, or any one of these becomes active, so that our data is safe. So that we call it as replication factor. Okay, so this, we understood what is data node, we understood what are blocks, and we understood what is replication. Now we have one more person here. The very important person is name node. Name node is a master. We call it as a master node because this is the service which actually maintains the metadata of each file present here. So it knows, say for example, I give an example. The file 1 has two blocks and it is distributed in X data node and Y data node. Who has that information? Name node has that information. Okay, and when I make a request to write the data, he ensures that block 1 is present here and the replication is present in other systems, that entire algorithm or where exactly it is to be distributed, whether the block has to be deleted, a block has to be removed, or it has to be moved. And if uh, one data node has failed, or if one data node has failed, so where exactly the other replications are present, it has to activate it. Also, all these are done by our name node. So he is the master. So that's the reason we say this is a master and slave. Data nodes are slave, so we call them as, that's the reason we call it as a master slave architecture. Okay. And did I leave anything? Yes, the racks. The the rack is nothing but the collection of the data nodes that we have in a cluster. So what is a cluster? The cluster is the entire Hadoop setup. The entire setup where you have multiple networks connected together, multiple systems like data nodes are connected together, and we have name node. The entire operations, the entire Hadoop Hadoop setup is called the cluster. So within cluster, you will have racks, which is a collection of data nodes, and other services running like name node and data node, and the block operations happening here. And I think I left this one. Yes. So I gave an example of writing the data, right? So how the data is written, and who ensures that the blocks are split properly? The name node. Here, when the data is read from the client, and name node will have the information which file, when the request for file X, the name node will have information where exactly the blocks are saved for each file. So that is given to the client by the name node. That is the metadata operations. So this is a very high level architecture. I've explained. There are so many other services. So once we start installing the Hadoop, we can see what are the services that we have and how does each one of them work. Okay, so this is a very basic architecture introduction I gave just to give you an just to get familiarized with the HDFS architecture. Okay, so if you can just take a look, and if you have any questions, let me know. So I'll quickly summarize or give you an overview of Hadoop or the HDFS features, so that you will come to know why it has been widely used, and then in the coming sections we can get into each one of them in detail. The HDFS architecture before I wind up today's session. So with this you can uh, understand the scope of architecture, the scope of Hadoop that we have in the market. Okay. Okay. So if I just want to say the features of HDFS or Hadoop, so it is actually fault tolerant. Okay, before that I want to say Hadoop is designed to be installed on the commodity hardware. When I say commodity hardware, a very cheap hardware. So before a few years ago, storing the data was very expensive. But now with Hadoop or the HDFS, it is not, because we can store our data in our system. Okay, so that's the reason they call it as a commodity hardware, and it is fault tolerant. When I say fault tolerant, I just give you an example here. The replication. Uh, this replication ensures that our data, which is spread across. So I gave an example of file 1. It was spread here and here. So when there was some processing happening on this file, if this has failed, we have data saved somewhere else. So name node ensures that the data is taken from here. So by that, it is fault tolerant. So we don't have to worry that if our data is lost, we have a backup somewhere else, right? This is another feature. And this is very easily scalable. When I say scalable, for example, your project, so for example, you have 2 data nodes here or 5 data nodes here, okay? And now your project wants more storage. Your project is growing and you need more storage. So what do? it's very simple that you add another data node, okay, or I mean, for now you can just imagine it's another system which has a storage, and you can inform name node that a data node is present here. That's it. You don't have to shut down your system or make some changes within the systems, and then you have to restart, so that there is no there is your system is not hampered, your process is not hampered. You can just add one system with a storage capacity and inform your master node. So it's easily scalable, and also it is very easily portable. When I say portable, Hadoop or HDFS is a storage, right? So which can be easily connected to multiple applications very easily. Okay, so it is as portable as this. So you will have it's very easy. So you will have all the solutions available by Hadoop to connect to multiple applications. It's not that you have to connect to the Apache ecosystems. You can connect to multiple applications uh, required by you. Okay. So this is the very common features of Hadoop and HDFS, because of which is widely used. Okay. So this has made Hadoop easily used by everyone, because it's very cheap and it's very easy to connect to your different applications which you are already running, and it's very easy to store your data as well, and it's very simple to understand. So that's the reason it's commonly used by everyone. Okay, so this is what I wanted to give an uh, I mean, this is what I wanted to tell you today. But going forward, I'll just give you an highlight of what we are going to do in the next coming sessions. So we will install our Hadoop in different modes, like as a single system on a multiple systems, and we'll see how the distribution system works, and we will understand the architecture of HDFS. This is one of the component, and we'll also understand the architecture of the MapReduce. So how exactly the MapReduce works, and we can also explore, or we can write one MapReduce program and see how easy or difficult it is. And I'll also introduce you to some of the uh, processing systems like Hive, HBase, Scoop. We'll install and we'll work on it practically. And, yes, I can also give you introduction to Scala as well, because I am working on that. You can also explore the architecture of all the components of Hadoop. Okay, so this is the agenda for the entire course, and this is what I have for today. So I'll just quickly summarize what we went through today. We understood what is the big data, Hadoop. We were trying to differentiate between big data and Hadoop if we had a confusion. And within Hadoop, we have two components mainly. One is MapReduce and HDFS. MapReduce is the processing part, and HDFS is the storage part. We just explored the very high level architecture of HDFS. This is the Hadoop distributed file system where exactly your data is stored. And we just gave an introduction to the features of HDFS. The Hadoop ecosystem, yes, I can take you in the next session because of time. So the Hadoop ecosystems are the different systems that you can work on, like Hive, Scala, Spark, HBase, Phoenix, like that. So I can give you more details on them in the future sessions. Okay, so uh, this is what we have for today. So if you have any questions,